Here we go. Okay, so yeah, challenge worksheet, not due. This feels like a little out of order. I guess we'll walk through this quickly. You know what? Let's not, 'cause we don't need this yet. We're going to save this until Wednesday. What we are going to do is the back of that page. This is Monday, Tuesday lesson, and then Wednesday will be what was on the front. So a few of you, when we walked in, you said, what are we doing today? And I said, do you remember what 1 over x looks like? And if you do, you're good. If you don't, well, your reminder. Can you draw it with 2 hands in the air?
Yeah.
Let's see it. I want to see some workouts being done here. It's also enjoyable to try to watch you coordinate your hands to do that. Right? Is that the way? Would you be seeing this the right way, or do I need to do this the other way for you?
You just say it's negative or something.
First quadrant, third quadrant. All right, there's our parent function for 1 over x. And we know about transformations, like moving it, shifting it right or left, shifting it up or down. What does the h do? You tell me. Moves it to the right or left. So that in there with x. If it's in there with x, it moves it with x. So that's an x shift. And what does the k control? Yeah, just say up and down. It's not the y-intercept because this thing doesn't really have a y-intercept. But we'll say it moves it up or down. And then what does that a out front do? Stretch it or compress. So today's one of those days where we sort of overlay 2 things that we already know, or in theory we already know. Right? We know what 1 over x looks like. That's the choir director graph. I don't know how to direct. This is probably not what they do. But that's what I think when I'm making that. So we know that. We know about transformations. But now we got to put kind of both of those things together. Think about the parent function, apply these transformations, and get our new graph. That's today and tomorrow in a nutshell. Obviously, we need to do some examples and go over some things, but that's the sort of combining 2 things that we already know. Okay, the vertex. I think we should put that in quotes because that's not. The vertex is. What they're calling the vertex is that spot. I don't really think of that as a vertex. Right? More like I think the new origin would be a better name for that. Or the center of the graph. I'd rather call it that than the vertex. Because vertex I think of as parabola, maybe absolute value, but definitely not 1 over x. So I get what they're doing. That's the new center of the graph, the new origin of the graph. And then they write down what we already said. The a is the stretch or compression factor. H controls whether it goes left, right. K controls whether it goes up or down. It doesn't look like we have any of these, but what if a is negative? What would that do?
Flip.
That would flip it. So that would put it in the other 2 quadrants if we had a flip on there. Okay, so some examples. Let's see. Vertex. Again, I don't like that name. I know what it means. If you want to rename it center, that's fine too. Let's see. So how many left or right did it go?
4.
Yeah, right 4, right? Because the x stuff is backwards. So right 4. And how many up or down? 5 up. So our new vertex, and our new center, our new origin is 4, 5. And what's the stretch factor? 3. Okay, why don't you try examples 2 and 3, and we'll pick on some people to help us out. About the new center, or the new origin for this graph. Good, -1, 2. Cooper, stretch or compression?
Compression.
By? I don't know, that was I just made that up. I think if you just put 1/2, that would be fine, but sort of emphasizing that that would be a compression. I didn't circle the first one as a stretch, so. Jackson, how about the vertex, or the center?
3, -2.
3, -2. Good. And Kennedy, the stretch or compression? That one's tricky. They put it in a different spot.
Oh, 5.
Yeah, they tried to hide it. Got some of you. So be careful on the stretch compression. It could be out front, but it could also be in the numerator, and it mean the same thing. All right, let's do some of this next worksheet together. Graphing rational functions. So I know the basic shape of this thing, but with a graph paper on here, I feel like I better be more accurate than just that picture. So what would be like one of the key points that this graph goes through? Well, if you don't know, you just kind of do a table of values. Yeah.
1, 1.
1, 1.
That's all.
And what about if we plug in x equals -1? We get -1. And that's kind of it for our key points, because we know what the graph, the shape looks like. We just needed a couple of points to make sure our picture was accurate. So it's kind of our key values there, 1, 1, and -1, -1. Be careful unless there's a stretch factor. If there's a stretch factor, who gets multiplied, the x's or the y's? The y's, because it's a y stretch or compress. All right, number 2, now we got some more instructions here. Identify the vertical asymptotes and horizontal asymptotes, x-intercept, y-intercept, domain and range, and then graph. I think what I would say, though, is graph, then do all the rest. Right? Because I know how to get the graph, and then I can use the graph to help me find the rest. So I think I'm going to graph first, and then handle the rest of this stuff. So I'm going to say center, although I guess I still think that's better than vertex. But it's not the center of a circle. It's not that kind of center. So, Carla, what's the center or the vertex or the new origin for this one? 1, 3. So, for 1, 3, that's not a point on the graph. So be careful. Don't put a point there. But what some people will do is they'll put like a little plus, almost a new axis there at 1, 3. It's not on the graph, but you kind of need to know where it is because you're going to graph based off of that new origin. Now, from that spot, I know I can go 1, 1 and -1, -1. There's my graph. So it's the same graph as number 1, it's just been moved right 1 and up 3. Okay, but I got all these other questions to answer now. How about a vertical, up and down, vertical asymptote? Asymptotes. The line it gets closer to but doesn't cross. And vertical means up and down. So my vertical asymptote is x equals 1. How about a horizontal asymptote?
Y equals 3.
Good, y equals 3. What's that, Ryan? Yes, it corresponds with the center. X equals 1 is your vertical asymptote. Y equals 3 is your horizontal asymptote. That will always be the case. So that's why I wanted to graph it first, find the center first, because that helps me find the asymptotes. Now, x-intercepts, sometimes you can get them by looking, sometimes not. In fact, I would say this one is a not. I can look and see the y-intercept. Let's do the x-intercept first, just because we're going in order here. So what's true always at an x-intercept? Y equals 0. So forever and always, if you want to find an x-intercept, not just in this unit, but any unit ever, you can set y equal to 0, because that would put you on the x-axis. So let's set y equal to 0, and then we'll figure out what x needs to be to make that happen. So this is sort of our first real math of the day here, equation solving. Let's see. Move the 3 over. What do you want to do next? Multiply by x minus 1. Negative 3 times x minus 1. What does that leave on the right-hand side if I multiply both sides by x minus 1?
1.
Good. X minus 1 cancel, but it's not 0. There's still a 1 there. And now I've got a algebra 1 type equation here. Negative 3x plus 3 equals 1. So negative 3x equals negative 2. And x equals 2/3. And that ought to match up with the graph. I mean, I know my graph isn't perfect, but I would believe that that's 2/3. So my x-intercept is 2/3, comma 0. X-intercept is a point, so write it as a point. Don't just write 2/3. 2/3, comma 0 is the x-intercept. The y-intercept, that's where x equals 0, but we kind of get lucky on this one because it lands at a nice spot, so I don't really have to go through the process on this one. What's the y-intercept?
0, 2.
0, 2. So again, we got lucky on this one because we can just see from the graph what the y-intercept is. If that doesn't happen, well then you plug in 0 for x and see what you get. Okay, looking back at the directions, I got vertical asymptote, horizontal asymptote, x-intercept, y-intercept, domain and range. Right, domain is the x values that the graph covers. So I'm looking at it left to right. Does it cover every x value?
No.
No, but all but 1. So the not fancy way to write that would be x can't be 1. Do you know the fancy way, meaning interval notation? Yeah, negative infinity to 1, and 1 to infinity. And obviously don't include 1, because the whole point is to not include 1. And this one didn't specify, so just make sure you understand both. Usually I'm okay with the easier one. The whole point is x can't be 1, so as long as you recognize that, that's the point. But sometimes we'll ask for it in the fancy way, which is interval notation. Range is kind of the same type thing. Preston, what's the not fancy way to tell me what the range is? So looking at our y values.
Oh, not fancy?
Yeah, give me the not fancy. Give me the easy answer. What's that?
Y third. Yeah, y can't be 3.
Y can't be 3. Yeah, that would be the not fancy way. That would be the I understand what's going on, y can't be 3. The fancy way would be similar to what we did for domain, negative infinity to 3, 3 to infinity. Again, sometimes we'll ask for the fancy way, but I'm more concerned that you understand the concept. Range is y values. You can't have a y value of 3, so y can't be 3. Number 3, let's look at number 5. It's already circled. Amazing. Megan, how about the new center for that? The new origin. Good. Negative 3, 0. So left 3, and then Megan was not thrown off by the fact that there's not a y thing out there. That just means there's no adjustment up or down. So we're still at 0 for y. So negative 3, 0. I'm going to go ahead and put my new axis there, my new origin there. There's not been any stretches on that. Ooh, what do I need to be careful about before I start graphing this thing? It's flipped. So normally we do 1, 1 and negative 1, negative 1. But because of that negative sign out front, it's going to be 1, negative 1. I don't know, this is maybe the long way around. Maybe you could just visually flip it over. And negative 1, positive 1. So there's my graph. Peeking back to make sure I just put them in the same order. Vertical asymptotes, horizontal asymptotes, x-intercept, y-intercept, domain and range. Let's draw them on there first. So I do pink for my vertical asymptote. So there's my vertical asymptote. Cole, what's the equation of that vertical asymptote? Good. X equals negative 3. Oh yeah, how about the horizontal asymptote? Good. Y equals 0. And again, it's always going to be those coordinates of the center. And x equals the x coordinate, y equals the y coordinate. All right, how about x-intercept?
No.
Why not?
Can't touch.
Can't touch y equals 0, so no x-intercept. If you didn't have the graph and you tried it like the equation way, meaning set y equal to 0, well, there's no way for that to happen. There's no value of x that will give me a 0 for an answer. Right? If x is negative 3, that won't work. If x is anything else, I can't get 0 for an answer. So some people, hopefully you draw the picture and realize, oh, there's no x-intercept. But some people are so process, formula, algorithm, do the same thing every time that they'll plug in y equals 0, which is fine, but then they need to understand that that doesn't lead to an answer. There is no x-intercept. Okay, y-intercept right there is the graph of the y-intercept. How do I find the y-intercept? Set x equal to 0. So y equals negative 1 over 0 plus 3. So negative 1/3. And that checks out with my picture, right? I mean, I can't get negative 1/3 off my graph, but once I know my answer is negative 1/3, that looks pretty good. So 0, negative 1/3. One of the nice things about this unit, in fact, this will be this unit all this week really, is there's so much information and it fits together. So if you try something and you get a weird answer, like you'll know it's a weird answer based on your graph. So it's, I don't know, maybe it's good news, bad news. Bad news is there's a lot of stuff to one problem, but the good news is it fits together, and so there's a little bit of a self-check thing built in here. Cash, I'm not feeling very fancy today. Just tell me what x can't be.
0. Oh wait, no, sorry. X cannot be negative 3.
X cannot be negative 3. Next level question here, Cash. You know why x can't be negative 3? Look at the equation and tell me why x can't be negative 3.
Because a fraction really can be 0.
Can't have a 0 in the bottom. So x can't be negative 3. Logan, how about range? What can't y be?
Y can't be 0.
Good. That one's a little harder to answer in terms of the equation. But you could say there was no up and down shift, so that asymptote is at the same spot. Y can't be 0. Okay. I think we're okay for you to strike out on your own. Not strike out like baseball strikeout, but like soldier forth on your own. So worksheet 8-3B is your assignment. Got 20 minutes left. So let's try one, and then we'll do one, or I'll do one in a moment. So you try number 1.
So we don't have to finish A3 A?
Nope, the rest of those are just notes, practice problems. But let's jump to the assignment. You try number 1, and then I'll do number 1, and we'll see if we get the same thing. So be careful, don't go to 1, 2. You're going to go 1, 2 from your new origin. And -1, -2 from the new origin. And our asymptotes still go through the center. Maybe it's good to draw those first. Because you can see it on the graph. That's what I was hoping you would say. Occasionally you get lucky and one lands exactly where you want it, and so you can just see it from the graph. Jack, how about the y-intercept?
0, -2.
And how did you get that?
I put 0 for X.
Yeah, that one, I don't think you want to trust your graph on that. It's not, I mean, I happen to draw it where it looks like that's right, but you shouldn't go by that. You should do what Jack did, and that's plug in 0 for X. So 2 over -2 minus 2, and yeah, -1 minus 2 is -3. So a little bit of work, but 0, -3, and then yeah, that fits with, hopefully fits with what your picture is. Joaquin, how about the domain? X can't be 2, and Carson, the range?
Y can't equal -2.
It can't be -2. Yep. So the rest of those are yours to play with and enjoy.